Hello everyone, welcome to Embedded Systems course with Arduino. In today's session, we are going to cover microcontroller based Arduino development boards. In particular, we'll focus on Arduino UNO. Then we'll go over the feature sets of Arduino UNO, which will be important to us in upcoming sessions on how to connect several peripherals to this board. Then we'll go over Tinkercad, which is our platform solution for designing these embedded circuitries. I'll give a brief overview of the platform. Then we'll go over one important peripheral or component which we use to connect to Arduino, and then we connect several other peripherals to it, which is breadboard. Okay, so let's begin. So Arduino in general is a physical development board which was designed by a group of people in Italy, okay, around 2004, right? And it consists of a microcontroller. So if you see, it will have a microcontroller, it will have several other power ports. You can supply power from here, right? So this is your power, and you will have several input output ports. So this will be there on all the Arduino development boards, right? So this is in general a development board which was designed by these group of people, and they have sold around 10 million units worldwide, right? Now here we are focusing on Arduino UNO, but Arduino has several families of boards, okay? So you can say there are families of boards, and these families of boards are decided based on certain factors. So the first important factor is, of course, what microcontroller you have on the board. Okay, so because there are several microcontrollers as we saw in our first session. Then what is the form factor or the use case, and then what is the frequency we want to set the application or use the application for, right? So based on this, there are several families of boards. So let's list down some common known families. So around four common known families are there. So one is your MKR family, right? Then you have your classic family of boards. So Arduino UNO, which we are going to discuss in this course particularly, is belongs to the classic family of boards, right? Then you have your Nano family of boards. So Nano family of boards are those microcontroller based Arduino boards which are used for your Bluetooth, then your Wi-Fi connection. So for example, ESP, Zigbee, and all that, right? And then you have your Mega family of boards. So Mega family of boards are very powerful boards because the uh, microcontroller used there itself is very powerful. So these are the some feature sets which are listed of Arduino UNO. We'll go to a more clearer diagram where we'll focus on this particular board, right? So if you see here, the microcontroller is highlighted very uh, like in a by this red box, right? So this is your Atmega 328. Actually this is P. So you will see this is the version of the microcontroller which is used for Arduino UNO. Now coming to basics, right? So you supply the power supply here. So you can give a 12-volt DC power supply here, less than 12 volt. So you can connect directly a power adapter which comes to this. So that will be convertible to around 5 volts. So the reference around for Arduino is 5-volt voltage. Okay. Otherwise, what you can do from laptops, right? So from your laptops or computers, because you will be ultimately dumping your firmware also, right, on this. So you can connect this also. So this will also supply power. But so in addition, as I said, this USB plug will be used to dump firmware also. Dump firmware. Okay. So now this firmware in Arduino language are known as sketches. So you can remember these terms sketches, right? Now we will go over the input output port. So in general, this is a 5-volt uh, this one actually is a 5-volt reference pin, right? Then you have a digital ground, right? So this will be zero, around 0 volt, right? Now these digital IO pins are configurable into input or output. Okay, so there are 14 pins including this digital ground. Now you have your serial TX and RX. So these cannot be considered as digital outputs or inputs, right? Then you have a reset button. So if you press this button, the Arduino board or the firmware which is executing is reset. It will stop executing and come to its initial state. Then you have this in circuit serial programmer. So this is used for serial communications, right? And then you, of course, you have your microcontroller which we discussed. This is your Atmega. Now you have your 6 analog pins. So these analog pins can take several levels, right? So if you the max is 5 volt and it can take up to 0 to 123. So if you divide that many levels it can have, analog voltage levels it can have. Now what are these? So these are your there are 6 power pins. So these are your power pins, right? So voltage in again you can supply the board or power up the board, right? From here you can connect to this. Now you have your 2 ground pins, right? You have your 2 ground pins. Now these 5 volt power pin you have and a 3 point. So why you have two voltage level power pins? So because there are several peripherals which can connect to 3.3 and some can connect to 5, right? So to accommodate all, so we have 5 and 3.3 volt power, and this is a reset pin to reset this Arduino board externally, right? So this is in general a brief anatomy of Arduino UNO which we'll be using, and it's important that we know the functions of all these at least what are present on this board on the top level, right? We know the functions of all these input output, our controllers and all these ports. So in general you also see this, right? So this in general is what, this is a USB chip. Since we have a USB plug-in, right, from here USB port, so this is used to convert the protocol into Arduino understandable format. So this is that USB interface chip, and this is your 16, this is your crystal oscillator. So what is the frequency of the clock on which this Arduino runs? It is 16 megahertz. Okay, so this is that crystal oscillator. Okay, crystal oscillator. Okay, now so these are those important which things which you should remember about this Arduino board. Now let's go over to the next diagram. So here I have just given a outline using colors of these Arduino board. So the green ones, of course, these are of course 14 digital pins are there, right? So 2 to 13 and including one ground, right? This is an analog reference of 5 volt. This is serial TX and RX, same what we have covered in the previous diagram, right? This is in circuit serial programmer used for serial programming. This is then you have your reset button, right? uh, you have your reset button here, right? So you can say this as your reset, right? And then you have this Atmega. This is your Atmega microcontroller, right? Then you have your crystal oscillator. For of course you will have your crystal oscillator here which we discussed. Then you have your USB chip, just what we discussed in the last, right? And then this is your USB port, USB. So this particularly is your you dump your firmware, here, right? And of course this is your power supply, your power less than 12 volt DC, right? So this is in general an outline in colors which you can represent for your understanding, right? And of course we saw that here are the power pins. There are around 6 power pins and 6 analog ports, right? So let's go over. Now of course we saw that Arduino has Atmega 328P microcontroller, right? So that particular microcontroller has RAM, ROMs. We discussed all those, right, in our very first session. So now flash is also a type of ROM. So what is the size of this flash? So it is around 32 KB. Now this I am only talking about UNO boards. Okay. Now this can change for other boards. Okay. So out of this 32 KB, so if you see here, this 0.5 KB is used for your bootloader section. Okay, the bootloader code will be here, and rest code will be your firmware code. Firmware code will be in this section, right? So whatever softwares you write, that will be dumped into these sections. Now you have your RAM. So the data memory of RAM, so size is 2 KB. So what is RAM used for? RAM will be used for this external RAM which you see, right? So this will be of 2 KB, which will be used for manipulating the variables which you write in your firmware. And this, of course, the data content will be lost once you power off the Arduino. So this data content will be lost. Now, of course, you have again EEPROM, right, which is electrically erasable programmable read-only memory. Again, a type of ROM. So what this contains, this is the size is of 1 KB, and this contains certain functions or tasks which are needed and which are by default always needed to be dumped as a part of firmware, right? So we will those see those functions, those are dumped in EEPROM, right? Those are always needed. Okay, so now if you see, I have this particular board, right? So this is the Arduino UNO board, right? Exactly same what we saw in the diagrams, right? And we'll also see this in our software platform, this exact board. Okay, so right now breadboard, right? So now you saw that there are 14 digital ports, there are 6 analog ports, but how do we connect several peripherals or several wires, right? And power many, if you have suppose an LCD which has several ports, so how do you connect the pins over there to Arduino? You cannot connect directly, right? So you can create a combination of power supplies, right? So that is what this breadboard helps us. So let's get a brief understanding of this breadboard. So now if you see here, right, this minus row here, right, right. So this particular will be all connected. So if you connect one wire and connect it to the ground of Arduino, right, so all this will be at ground, this row, and then this row, so you can say this at 0 volt, right? And this particular row, right, this particular plus row, we normally connect it at 5 volt, right? So now you have a 5 volt row and you have a 0 volt row. You can take the wire and connect to here. So here if you see row wise, right, so the first column, I'm talking about column now here. So 1J, 1I, 1H, 1G, 1F, right, which is listed here. So these all will be connected together. These are always connected together. So whatever the power supply or whatever the voltage level you give at this point, all the 5 will be at the same voltage level, right? So that is how this breadboard is. So even here, so this here will be all connected, okay? And right, so and then again you can connect a 0 or a 5 volt power supply to this. So this will help you create several connections and give you several wired outputs to connect your peripherals. So this is in general what a breadboard is used for. There can be several other breadboards, right? But in general, just to understand and what we think we have to take care, that here the all this particular row will be at the same voltage level, and here the columns will be at the same voltage level, right? So it's not, if you correct, if you take a wire from this minus and connect to here, so it will be at 0 volt. But if you take here and connect second column to this 5 volt, right, if you connect here, so this will also be become at 5 volt. So now this 2, right, so this second column will be at 5 volt and first will be at 0 volt, right, first column. So this all these ports will be at 5 volt and this will be at 0 volt. So this is how this breadboard works, right? And it gives you a lot of flexibility, right? So now let's go over. So now we decided that we will design embedded circuitries using Arduino. So the platform which we'll use is Tinkercad. So let's go over this Tinkercad. Okay. So now if you look what is a Tinkercad. So I'll just go over, and so if you log in, right? So you will see you'll see several options to create your designs. I'll show you from the very beginning, right? So you can create here login, right? Log in with your Gmail account, right? So this is basically a 3D app where you can create 3D designs, electronic circuitry. So we'll be using for our electronic circuits. Now you can create this plus create button. So here you will get three options, right? You will see 3D design, circuits, and code blocks. So the thing of our interest is circuits. So I have already created a new design. So I'll just show you in this session. We'll go over how to take those components. Okay, so let's go over a very basic one, right? So you can click here, tinker this. Now see, you will see this particular window. Okay, now this particular window, the most important thing of use for us is our code window, right? So this will open up. Right now we'll discuss this in detail, how to write the code and what are the syntaxes and all. But how to get the components, right? So here you will have options, basic or all. You can select all, and you can search here. If you search here Arduino, right, what you got Arduino UNO R3, which I have picked it here, right? You can also search, for example, resistor, right? So you will get resistors, right? You got this resistor. You can set the resistance, right, in ohms, kilo ohms, as a part of this component, right? And then, for example, let's take LED, right? You can take LED. So this LED, you can change the color also. So for example, if I click on this component which I took, you can change the color from here. Okay, if I take this resistor, you can take the resistance and change the value. I have right now 1 kilo ohm, the resistance value of this resistor, right? But now what we took is Arduino. So basic thing of interest for you is that this is the exact same thing what we saw in the slides, right? You have your digital ports, right? You have your power button, then you have this your reset button, right? And then you have this at mega 328p, then you have six analog power pins, right? And this is your main power adapter, but what they are connecting is a USB plug, right? They are just mimicking how you will connect from your laptop to this Arduino, how you will power up this Arduino board, right? So now what they did, as I said you, breadboard, we took a breadboard also, right? So you can select here breadboard, right? Breadboard small, so you will get all these options, right? So now I took a breadboard small, right? So now what I will do is we will do this in all our embedded circuitries. So what we took the ground, right, power pin, and connected this to the black one which you see, the black wire, right? So in your real hardware, your physical hardware, these wires will be your jumper wires, right? You can call them jumper wires. So now we took this black, this highlighted which you see, right, which I have highlighted, we connected this to the minus, or which means this is now will be at 0 volt. Okay, now this red, right, we connected, if you see here it's written 5 volt, right? So this particular row, right, we saw that this all will be at what, 5 volts. We also gave the same, we connected the wire black to this, so this will be minus row will be again at 0 volts, this plus row will be at 0 volts, right? And in future now we can use these, outputs, or these rows, these columns 1 to 30, right? So you have so many options to give power supplies to this and connect the peripherals. So peripherals for us here were here LED, right? So we connected this to one of 19th row, right? And now we are connecting a resistor from 0 volt row, right? So 0 volt, we are giving 0 volt to this part. This is your cathode, right? So this we'll see in detail, but this is how we are getting much more flexibility to connect your, breadboard, right? So this is a this gives us that flexibility. This breadboard gives us that flexibility, right? And in next session onwards, we'll interface LED, buzzers, LCDs, motors, and all those with Arduino, right? So this will be our platform to take care or designing all the circuits. Also, what I wanted to show you is that this Arduino, right, is an open source platform, as I said, right? So you can get all the information on this HTML link, which is www.arduino.cc. Okay, so here if you click on hardware, right, so you will see many family of boards, like we discussed in our very first slide. You have MKR family, you have Classic, Nano, Mega, and if you click on Classic, you will get your UNO R3, which is our development board for this entire course. And here you can get all your tutorials, you can get your tech specs, whatever we have discussed. What is the USB connector? What is the microcontroller? How many IO, digital IO, analog IO? What are communication protocols which are present, what is the power voltage, and all those things are part of this HTML link. It's very open source and you can go over them to get more complete information. But as we build more and more circuits, we'll be more clearer on the Arduino board and its functions, and we'll also go over the coding guidelines in the next session, right? So thanks for joining.